All right, now here is the last example for today's class on surface friction. Now, this one is going to be very interesting. So, this is not a diagram drawn wrong. This is actually what it's supposed to be. So, on the right hand side, you have a wall. Okay, so this is wall on one side, and on the left hand side, you have a book. Okay, so now you know you can do that. You can put a book on a vertical wall, and then you can push it in with an applied force. And what you discover that is if you push in hard enough, you can actually get the book to stay on the wall without dropping. Now, but that's actually kind of weird when you think about it. Because I can do this, I can say, well, let's say I have a force pushing into the wall, which is called the applied force, right? Now, let's say the applied force in this question is at 45 Newton. Okay, we'll give it to it, 45 Newton. Now, I know that when we are on, because we are on Earth, there must be a gravity, a force of gravity. Now we also know how much the force of gravity is because they tell us that the book is 1.1 kilogram, right? So we can say, well, force of gravity is mg. If the mass is 1.1 kilogram, we multiply that by 9.8, and we get 10.78. Okay, Newton. So this force of gravity is about 10.8 Newton. I guess we'll just take one decimal point, 10.8 Newton. All right. Now, if you look at this diagram and use what we have learned about free body diagram in the past few days, you say this system, there's no way this is stable. I mean, who is fighting gravity? Now, you have to consider this because if your answer is, hey, no one is fighting gravity, well, then why is the book staying on the wall? Shouldn't the book just drop because gravity pulls it down? Or you might also ask, well, what is fighting FA then? Now, because if your answer is no one is fighting FA, I don't care who is fighting, well, it doesn't work. If no one's fighting FA, the book is going to submerge into the wall, which is really, really strange. Now, we don't see that happening in everyday life. So there must be something missing in our picture in here. Now, one thing that is missing is actually the normal force. Now remember, normal force, although for the past many examples, our normal force is always paired up with gravity, right? We have gravity going down, normal force going up. In this case, is not anymore. Normal force is not opposite to gravity. Don't make that mistake. Normal force is perpendicular to the surface. Now, where is the surface? Well, we have a surface called the wall. Our normal force is always perpendicular to the surface because where does normal force come from? It comes from, now let's say this is the wall. I'm drawing it on the side right now. Remember the wall has some electrons on it and it's repelling the electron. Oops, that happens. And it's repelling the electrons on the surface of the book, right? So this electron repulsion is what gives us that normal force. So normal force is always perpendicular to the surface. Now, since our surface is vertical, our normal force is going to be pointing to the left-hand side this time. Okay, so that's our normal force. And we know exactly how much that is because it has to fight applied force. Normal force is to the right, to the left. Applied force is to the right. If they don't fight each other, I don't know who will. So normal force going this way. Okay, so now we look at, so we have gravity, we have applied force, we have normal force, and we also have friction. Now, friction must fight in the opposite direction of gravity because if friction is not fighting, no one will. In this picture, no one is fighting to the upper direction. So friction must be fighting this way. Because without friction, your book will drop down. Therefore, friction helps you stay up or at least slow you down, right? Okay, so, but we know exactly how much friction is. Because if friction has to fight gravity, then gravity is 10.8, friction is also 10.8. So 10.8 Newton. Therefore, in the situation where everything balances out, we can again say, well, net force must be 0 because no one is moving. All the battles are completely balanced. And remember, we can use friction equal to mu Fn, solving that equation for mu. which will give you friction over Fn, my bad, friction over normal force. And then we just take friction, which we know is 10.8, and we take normal force, which is 45 Newton, and we divide it. Okay, so at the end, friction is 0.24 between the book and the wall. All right, so now we have done all the examples for this section today. So now you have one more weapons in your arsenal, I guess. So after force of gravity, after the universal force of gravity, now you also know how to calculate force of friction. So your homework is the worksheet down here. So the worksheet is worksheet number 3. So homework is worksheet number 3, force of friction, which is of course attached to the end of your notes. So you should have all of that already. The video should be up online on the courseware page. Of course, you go into Physics 11. It should be up online very, very shortly. And I will see you all on Thursday. All right? Goodbye.